Welcome, everyone. My name is Dave Stevens, also known as Laser Dave. Welcome to this month's third Thursday. This Thursdays, we are going to be discussing lasers for education. Thank you so much for joining me. Today, I have a special guest joining me today, Ken from the Makerspace. Hey, welcome, Ken. Thank you so much for joining me.
Thank you. It's great to be here.
Tell me a little bit about your Makerspace, Ken.
Makerspace is located here in Austin, Texas, at a very small school called ACE Academy, and we have just built out this summer a complete Makerspace that the laser is an integral part of it, but really everything from software to electronics to lasers and 3D printers, kind of like the body of the machine, the electronics and the software. Whatever you need to do to hack the world around you and make something you think should exist is in this space.
Awesome. Well, Ken is here to join me to answer any of your questions. If you have any questions for myself or Ken regarding this seminar, going over all the different details of educational type processing with your laser system, feel free to go ahead and post them during the course today. And at the end of the course, myself and Ken will go through and answer those questions. And let's go ahead and throw up Ken's website here so that you guys can maybe take a look throughout this. Ken's got a great site here. It's going to kind of show you what he does, how he's set it up, and maybe spur some of the questions that you may have throughout the course. So let's go ahead and shoot to my screen here, and then we will go through this course and then come out at the end with your questions. Okay, this course is on education and working with laser systems. If you are not familiar with QR codes, this course uses a lot of different QR codes. QR codes are pretty simple to use. All you have to do is just turn on your camera app, point it at the QR code, and it'll immediately give you a link so that you'll have access to websites, videos, files that will be provided during this actual course. So this course will also be recorded so that you can come back at a later date and access these links when needed. Trotec is a very social company, so if you want to keep up with current events, current trainings, new products, new materials, new processes, new applications, please follow us on YouTube, Facebook, Instagram, LinkedIn, Pinterest, or Twitter so that you can be kept up to date with all these different constantly changing facts in the laser world. So let's move into it. Working with laser systems and education have kind of grown together over the last 20 plus years. I've been in this industry for 21 years, and education has always wanted to stay up to date with current and modern technology. And lasers have always kind of been that pinnacle of technology. If you can process with lasers with the education, it really sets you apart from many others that don't have this technology. So I'm going to go through and kind of explain why you would need lasers in your educational workspace, what they could be benefit for, how they could benefit you, how to get them, and pretty much hopefully answer most of your questions, if not all your questions regarding this. When it comes to processing in the educational process, laser technology is prevalent in a wide variety of industries and career paths. And so education tends to promote training so that a person or a student can go towards many different markets. Because lasers are so diverse and because they work with so many different markets, materials, and applications, learning the process of using a laser really does give you a variety of industries and career paths into the automotive, aerospace, manufacturing, engineering, architecture, electronics, and signage, as well as so many more. Now, the laser systems are actually pretty easy to use and to learn. The difficult part about learning a laser system is really creating the graphics and elements so that the laser system can produce what the product you want. And so the main thing about really understanding laser system is graphic design. The actual operation is easy to run. I can teach somebody how to run an actual laser in the matter of hours. The difficult part is the graphics file skills, and that's where a lot of the training and education comes in. So learning different products and programs such as Adobe Illustrator, Inkscape, Photoshop, Corel Draw, as well as others, will help build those resumes. Because without knowing how to draw a specific element, the laser is not going to be able to produce that element. And so that's where the education comes in, and that's what we're going to cover a lot here today. A laser is definitely a worthwhile investment. In addition to education, laser can also be used for creating your school signage, making staff student recognition awards, plaques, trophies, directly marking or creating durable goods for the schools, equipment, inventory. More schools use it for tracking, inventory, asset tagging, engraving onto their tablets, their computers, calculators. And so beyond the educational standpoint, there are so many different benefits that work with the laser system, and it creates this this process for working. So school branded items to sell on the school store for fundraising purposes, tumblers, keychains, pens, pencils. These are all benefits for owning a laser beyond the curriculum and educational standpoint. So what is laser technology? And we're going to go through a little bit about what it is, how it's going to work, and realistically what Trotec offers in this marketplace. There are two major types of laser sources, at least that are most prevalent in this industry, that work with most of the materials. There are CO2 lasers and fiber lasers. The CO2 laser is a 10.6 micrometer, and it's the most common laser in the market for processing materials. It can process, in my estimate, around 70 to 80% of all materials on this planet. The additional laser that we offer is a fiber laser. A fiber laser will process an additional 10 to 15% of materials, and between the two of them, these two wavelengths can process most, if not all, materials, or at least react to most materials on this planet. And so this is why the two wavelengths that are covered the most. There are lots of different lasers out there, lots of different wavelengths out there, but these two wavelengths are going to consist of probably 98% of all materials out there, and it can work with those materials. Trotec offers one of these lasers, as well as dual source laser machines that combine both the CO2 and fiber laser within one machine. So the ability to process materials with one wavelength and then switch to the other wavelength to work with different materials all in the same machine are possible. Besides the type of laser, there's also two types of motion system or delivery system that we offer. Trotec laser offers flatbed, also known as a gantry motion system. This is the most common. And this is how the laser beam is delivered across the field. So you put your product into the field, the XY motion system or gantry motion system will deliver the beam anywhere within that field. The other one that we process, or the other type of motion system that we produce, is the Galvo system. Galvo system is a high-speed marking system that's typically fixed over the surface of the part, and then can deliver using mirrors to basically direct the laser beam onto an object. So combining with a CO2 can be used with either one of these motion systems, or a fiber laser can be used with either one of these motion systems, and able to deliver that laser beam onto the product, material, or application that you're working on. Different applications tend to work better with certain different motion systems and lasers, and we're going to get into kind of what types of lasers there are, how they work, as well as what's best suited for each one of these laser wavelengths as well as motion system types. Trotec's first kind of entry-level system is our on our flatbed side is our Rayjet 50 and Rayjet 300. These are two smaller laser systems starting at 18 by 12, which is our Rayjet 50, up to 30 watts, and then a Rayjet 300, which is 29 by 17, up to 80 watts. These machines are primarily only CO2. They're going to work with just about all your most commonly known materials out there. We're not going to be able to cut metals, stone or glass. Basically, a CO2 laser will work mainly and work the best with combustible materials. So if you want to cut a material, if that material is combustible, the laser can cut it. If it's non-combustible like stone, metal, or glass, the laser may be able to mark it, but it will not be able to cut through it. Materials like metal, even with a fiber laser, you can't cut through, but the Rayjet series machines are going to work with about 80% of all materials out there on the CO2 side. Also in the Rayjet series is the R series. These are the larger formats, mainly for cutting. They're not fast engraving machines, but they are large format entry-level flatbed cutting systems. So it keeps the cost low and gives you a large format for cutting much, much larger products. The R systems are ideal for, you know, a budget-conscious school that needs the ability to cut large individual dimensional letters, or making large signs, or needs that ability to have that large field without that high cost. Working field sizes up to 40 by 24, as well as our 500, which is 51 by 35. These systems may not engrave as fast, but they can engrave, and they're ideal for cutting. The next series Trotec offers is the Speedy series. The Speedy series is kind of the rock star of our product line. Definitely the most popular because they combine the best of all worlds. Fast cutting, extremely fast, by the fastest engraving on the market, and they kind of give you the best of both worlds in the fact of speed. They also work with both CO2 and fiber, unlike the R series and the Rayjet series, so that you can place a CO2 machine or a laser on board one of these machines, or you can do a combination of both the CO2 and a fiber laser. So these systems, in addition to being the fastest engraving and the fastest cutting speeds, kind of give you that all-in-one type system. Lots of different materials also are going to work with those fiber laser materials, marking, cutting, engraving. Ranging machines start at 12 by 24 and can go as large as 40 by 24. And then we have our SP series. Our SP series is our large format laser cutting systems. These will also engrave, but these are primarily used also for large format cutting. Systems can go up to 400 watts and working areas up to 87 by 126 inches. These give you the ability to really cut large products, to be able to handle those large products. They have multiple zones on them, so you can be cutting on one side, especially if the large flatbed machines like our 3000, our 2000 and 3000 you see here. One side can be loaded while the other side's being run. So a lot of benefits and advantages for running the large format machines, especially if you have those products or materials that require the larger physical field size. And then finally, we have our Speed Marker series. This is our Galvo line of laser system. Lots of different types of these machines. These are available in both CO2 and in fiber laser. They are the direct mark material. Much smaller field, but we can also move what's called segmentation, where the head can move over the product, so we can do much larger fields on these systems using the different Galvo beam delivery system. Lots of different choices. Trotec makes a huge line of laser system and ultimately gives a choice of what's needed and also a growth path for maybe starting out at a small end and then maybe eventually going to a much larger or a Galvo system to fill those niches, needs, or wants for specific applications or materials. So where would you use lasers in education? Educational benefits are vast, and in the 21 years I've been in this industry, it just keeps growing. I've seen education products being used in incredible, research and development stuff in the high education, all the way down to elementary kids' schools cutting cardboard to make out products. So it really does kind of give that ultimate Swiss Army knife style of tool to work with so many different applications and materials. And that's why they're so adopted into schools these days. Starting with the elementary, we have many schools that benefit younger students teaching younger students about laser technology. As this industry has grown, it's becoming more and more easy to use. It's becoming safer. It is more cost effective. It's more adopted into schools. Kids are learning more and more high-tech type applications, and so it is crucial to get it into the earlier stages to increase their interest in technology, interactive learning tools that can accommodate a variety of subjects, and it also promotes hands-on. because not only are you visualizing what lasers are, you physically get to see it, you watch it physically cut out, and then you get to put those products or parts together if you're physically cutting products. And so elementary education is a big one. Curriculum ideas for the elementary, just covering laser safety, what lasers, what they are, how they work, what materials can process with the lasers, kind of understanding how beams and laser light reacts and is focused to a small point. And then we can literally allow photonic energy or beams of light to do our bidding. We can make it conform to working with all these different materials and applications to produce products. It's very practical in the fact that you can do basic cutting and engraving applications. You can have the elementary school create their own nameplates for their desk, and we can start out with some pretty simple stuff. Practice different fixture methods to hold materials in place using magnetics, tapes. But the real neat thing is the ability to very, very quickly take a theoretical thing, something like lasers, and show students of this age what they can do by physically showing them running the machine. Typical lasers for this marketplace for the lower end is going to be our Rayjet series. Rayjet series and the smaller little desk machines or desktop machines working with materials like cardboard. Cardboard is inexpensive and free. You can have students bring it from old shipping or cereal boxes. They can be cut out. I've seen students just pick pebbles up, dark stones off of the ground and bring it in and laser engrave their name on them. Tree branches. Really doesn't have to cost anything for the materials in order to take that lasers and actually place a graphic or something onto it. Other materials like wood and MDF are probably some of the most common for this age, as well as getting into some plastics and acrylics. The Rayjet series and the ARG series are typically used for this, keeps the cost low. It allows for smaller units. Is typically, there's typically not as high of a budget for this type of age group. Couple simple applications I'm going to show you and show you the exact process of how it works using our Ruby software. I'm going to make a simple name plate, and then we're going to make a simple actual room sign. And so this is a common application that can be done. The process can be shown. Nameplates can be made for all the students. The room can have all the signs made. And so I'm going to go through and kind of show you the process of how this actually works. So this is our Ruby software. The Ruby software is used to run the laser system. And the benefit of the Ruby software is that it is incredibly user-friendly. Trotec has recently switched to the Ruby software. The Ruby software gives us the ability to basically run web-based. So students can operate this laser system from a tablet. They can run it from a Chromebook. They can run it from a MacBook. They can run it from a PC or a laptop, anywhere within a network without actually being connected to the laser system itself. As long as that laser system is plugged into the network or on a Wi-Fi network, you have access to it. Once the students open up the web page, which opens up into Ruby, they can do a simple process and just you can draw directly in here without using design software. So in this case, I'm going to just draw a simple box, put in a dimension in this case. So a simple nameplate would be 8 inches by 2 inches. Once I have the nameplate size, let's go ahead and add some text. And all this software to be able to design graphics are built within our Ruby software. So once we add the text, we're going to select the text, make a minor adjustment to scale it up to the size of the tag approximately. And then let's go over and change the font, something a little more stylish. And then because this will be more of a desk plate, let's bold it and italicize the text, make it stand out a little nicer. And then we'll drag it to the box itself. It'll auto snap to the center of the box. Lasers use different colors for operation. So I'm going to select the box and I'm going to change the outline red and we'll leave the text black. Let's fill it to the design. And then let's go ahead and create that job, sending it to the laser field. This is how simple it is to run. We'll then go to the laser system, placing our raw sheet stock material. In this case, it's plastic with basically a metallic looking surface and a black core. So the laser will etch away through. I'll bring the head over the top of the material, press the focus button. Sonar will find the height of the material and focus for us. and also show a red pointer on the screen, which allows us to snap our graphic to that location so that we can orient our product to the material. Then we'll just select the material of what we're going to laser process off of a list of preset materials for you, press the start button, and then the laser will go ahead and process it. As you can see, this plastic looks like metal. The software will actually start timing and show you the process on the screen while it's running. And then the laser will go back and forth, pulsing the graphic into the surface of the material, and then physically cut it out using each of the colors. So it's that simple. We're able to design a graphic within the Ruby software, which is built into our Trotec, which comes with our Speedy series of laser systems. And then we're able to design right from that design software the finished desk plate or nameplate in this case, and then cut it out, select the material, focus, and run it without the need of any type of software, without the need of learning CorelDRAW, Illustrator, or any advanced software. And so this is why the Ruby software is also ideal for the elementary type school, because you're not buying site licenses for additional graphic softwares. All you would need to do is apply an email address, and then those computers that you send the email to would then have access to this Ruby software. Here's a little bit more complex, should you want to go into the actual design standpoint, running out of Adobe Illustrator. So something like this would be a more complex type of a design, file design. In this case, we're going to take a cutout that's already been designed in Adobe Illustrator, and I'm going to make some adjustments to it. So in this case, I'm going to take and create a dimensional sign or a raised letter sign. So I'm going to save the Adobe Illustrator file, and then I'm going to just drag the Adobe Illustrator file in from another screen, and it'll drop right into the Ruby software. Then we're going to fit that file to design and create the job. So we don't have to do any actual designing, since the designing was already done in the Illustrator software. Then I'm going to position it to the red pointer like I did before, select the material. In this case, it's going to be black acrylic. And then I'm going to send that to the laser. Go ahead and place the black acrylic into the machine, focus, and then push start. The laser will then select and go ahead and cut out all the red color. In this case, I did 2 different colors. The red color is going to be identified by the Ruby software as a cut path, and then here it's cutting out the blue color. The blue color is a score or a marking setting, so it's not cutting all the way through, but it's producing an outline of where the letters will be. Then I'm going to go back to my file, and I'm going to delete out all the rest of it, because I'm going to make the word Mrs. Smith raised up on this sign. So I'm going to delete out what I don't want, because these letters are going to be physically cut out. Move them a little closer together, make them a cut path, and then send that to the laser, snapping it to it. And in this case, I'm going to cut out the metallic plastic. This metallic plastic already has adhesive backing on it. So you can see the adhesive backing there, and the laser is going to go ahead and cut out these letters. So we've got physical dimensional letters being cut out, and we have a physical piece of acrylic that's also being cut out. So now all we have to do is assemble this sign together. So this is a great little project. I will, of course, provide these projects at the end of this course, so you can download them, modify them, edit them, change the name. And now what I'm going to do is take the adhesive back and just peel the backing of each one of the letters, and then peel and stick them to the surface of it. And then I'm going to pull all the film off of all the products. I leave the film on while cutting, just in cutting, because it's going to keep any fingerprints. And now we've got a dimensional, 3-dimensional sign that could be put on the front of a classroom, can be put onto the wall. It could be produced in any way like this. And so that was a very simple sign, a little more complex on the design standpoint. So something like this could be as simple as a clip art. The graphic does need to be vector art for cutting. So this is where the complexity can come in when it comes to processing applications like this. But those were 2 applications I really wanted to process through and kind of show something a little more simple, just running out of Ruby, which is the desk plate or the nameplate. And then also a dimensional laser cut sign, something that would be practical for this space. Now, secondary education are going to be more your high school students, starting to think about the career path. Laser technology can demonstrate new opportunities that may not have been previously considered. There are numerous STEM scholarships available that can assist in making college more affordable for students that choose the science, math, or engineering major. And getting those scholarships can be learning lasers can give you that skill set and enable those students in order to get those scholarships much easier. If they take the initiative and learn laser technology and understand it, it's definitely going to give them a leg up in the STEM marketplace by learning these by learning lasers in the early education process. Some curriculum ideas for this: laser safety, maintenance, in depth into laser knowledge, such as wavelengths and wattage. Lab report to hypothesize how the different materials perform on the laser, color change, smell produced, how much power will be needed, necessary process speeds, power versus speed, role play, quoting time, labor, materials. I've seen a lot of schools actually create, design, and develop a product, and then engineer that product, develop the product, and then manufacture it on the laser for an actual cell, market it, and realistically show the entire process of what they would do in the real world. And so the learning profiles for this, and then actually selling that product to help pay for materials, to help pay for the laser machine, all can be practical when it comes to learning the laser system. Material ideas typically for this space is the whole gamut. Cardboard, wood, Trocraft Eco is a very popular one. It's an environmentally friendly, flexible material ideal for model making and design. Plastics, acrylics, textiles, stone, glass, metals, coated or uncoated, realistically anything you can think of. This is a great one. One of the materials that are very commonly done is your MDF material, because it's low cost material. But cardboards, plastics, woods, like I say, I mean, I've seen students bring in tree branches and, you know, engrave graphics onto them using the rotary device, 360 degrees around a tree branch, and just make some very unique products. This space tend to go into the R series. The R series ideal for prominently cutting. If you're doing a lot of cutting type applications, large format type cutting, signage, this is a common used system for this space. The Speedy series is probably the most common in this upper education. Speedy series is the fastest engraving and cutting machine. Top processing speeds for ideal larger classes because you can do more products quicker. On the lower education, elementary, middle school type stuff, you're not doing as much. It's more to produce a wow effect, maybe a little fundraising, maybe for some desk plates and to help the school. Where in this case, the Speedy series is ideal because it's going to be able to produce products, 3 to 4 times faster due to the speed of the motion system and the wattage of lasers available. So it's ideal for this age group. Couple sample applications that I put together here for this age group that's commonly done. Beyond just flat nameplates and stuff like that, become more models and prototyping type stuff. So creating products that actually are designed in a 2-dimensional platform, as well as then can be cut with the laser to create a 3-dimensional object. And so I'm going to go through these 2 projects. And again, all these projects will be available at the end of this course. You can scan a QR code. I'll show you at the end to download these files. So the first one is a model rocket. Here's a file that's already been created. Simple project. But the hard part about this project is understanding the material, really working with the different material to make sure that you have the thickness right. And then when you design the file, making sure all the little tabs or the tabs that actually allow the wood to fit together. So an educational idea would be to run small tests and actually cut tabs and into the wood and making sure they actually fit together. Once an exact dimension has been determined working with a specific material, in this case it is a veneered MDF with a bamboo face. So the surface, both sides look like bamboo, but the core of this material is made of MDF, which is very durable, strong material, like a plywood, but works better than plywood because we don't have those issues. Once the file is cut out, we will then go ahead and wipe the surface. I do recommend all wood is pre-finished so that the residue can be wiped off because the laser will produce residue on the front. And in the case like this, I will place a piece of transfer tape over the surface of the wood to pull out all the parts, but also to be able to flip them over and then wipe the backside of all the parts individually or very quickly. So this is a quick and easy laser hack for working with those products. And then you're going to lay out the products in this case. And if done correctly, this product should just put together very quickly. And so in this case, it's small to large for the little rocket, and then it's pretty simple to assemble at that point. So we'll just take the product and then we'll put it together. So if done correctly, these tabs that slide together should slide together and fit snugly. No glue may need to be required. Wood is very forgiving, and it's one of the materials I would recommend working in this case for these type of projects. You're going to find that I can, of course, make it look easy. I've been doing this 21 years, but a student that is actually working on a project like this is going to go through maybe many different renditions. Their engineering skills from their design standpoint to an actual physical product. Will it fit together? Will it hold together? Will it assemble properly? There's a lot of different what ifs when it comes to just a simple little project like this. So we've go ahead and put it together. All the tabs match together properly. No glue is needed because the offset or the tabs were created so that it was a very snug and tight fit. And there we go. We have a finished model rocket put together. Multiple parts were assembled together. They were designed specifically to be very, very tight fit. And we were able to create a three-dimensional object from a two-dimensional design that was conceived on the screen from concept to reality. And that's the benefit of a laser system. This type of a project can be over an entire semester, so understanding materials, understanding reaction, understanding how those tabs fit together, how they're going to fit properly. And then we can move forward with doing test cuts. And then finally, we can start to do components and then putting those together. Final drawings can be done, and then projects can be cut. Here's one that is also very popular, simple type application of more of a prototypes. And this was more of a concept of creating a product from a standpoint of engineering it, designing it, developing it, laser cutting it, and then possibly selling it. So this is a cell phone amplifier application that not only uses tabs and cutting, but we're also using hinged process. So this is called a living hinge. Living hinge is the process of actually cutting multiple parts onto it. We're going to open this into Ruby, select the material. In addition, this is a project that would be multiple materials combined together. So in this case, I'm going to take a sheet stock of a walnut veneer material as well, and then we're going to go ahead and cut it out. And then the hinged effect, after testing to determine the flexibility of it. Wood is very flexible, so you can do the offset hinged effect, and then we can cut that out. And I'll show you how it assembles here separately. Then I'm going to take my other materials, which are my two side panels, put in a different material, select that material off the list, and then cut that one out as well. This is a plastic that looks like polished metal. But again, it engraves black, but it's just much thinner, and it's got an adhesive back already. Trotec does sell most of these materials. I'll give a link for that at the end. And then finally, here's a frosted or a satin black acrylic that's going to be cut out of acrylic for the front grille of this project. So in this case, I'm going to engrave out the little pocket for the medallion on the front, and then I'm going to cut all the little speaker holes with the laser system into our frosted black acrylic. Once all the products are complete, we now have a flexible finished product. And something like this does take some serious engineering. You have to understand angles. You have to understand geometry. You understand tabs. You have to understand the flexibility of the material in order to conceptualize the design from concept to reality. Also working with different materials and understanding how those materials are going to react, adhere, and perform or bond to the surface of these, to the finished product to make it look like a finished product. Here's the final one to hold your phone in place. And then we'll place the little medallion onto the surface. And then we have our little phone, cell phone amplifier. From, again, concept to reality, from just a couple different materials. We used a plastic. We used an acrylic, plastic with an adhesive that looks like metal on the side. We used a walnut-style wood, and then we combined it all together to create a finished, very viable product that would be it's adopted and purchased by people should they want. Here's a few testimonials that come from schools. Basically, students see the possibility of what they can create with the laser, and they can't wait to jump into the project. That was Dale West, a STEM teacher from Juliet High School in Juliet, Illinois. You would be surprised when students get a hold and they see that their drawings from the screen can physically create products, they're going to run away with it. And that's what this statement indicates. Well, I mean, working with, say, a Speedy 100 prototyping, the laser can quickly create multiple iterations of the design, encouraging students to problem solve, working with different materials like plywoods, mainly acrylic, sheet materials, kind of like the last project I just covered. But you would find you'll find that the problem solving skills, I cut this out, the angle is wrong, the cutting tab's wrong, I didn't account for the beam diameter or the kerf of the laser, so it's a little bit loose, maybe I don't want to glue it together, this material doesn't work as well. So it really is interesting to watch that those gears turn in students' head of what they can do to solve those problems. And that's it is truly encouraging to watch students build these types of projects. Here's another one. Application, catapults, chessboards, floor plan engraving, school-related signage, ornaments, keychains, engraved phone classes, and more. Testimonials. Great examples of how students can laser cut these different designs into a piece of woods. Students quickly figure the laser out. After a few projects, it still amazes me how the students can take a design and create a physical model. Dale West. It is amazing. I was struck by this 21 years ago when I saw it the first time. My eyes lit up because my designs, my conceptualized in my brain, could now become reality. And that's what you'll find, especially students that have those aptitude towards more of a technical background or a technical understanding of what's possible. And you'll find that they run away with it. Another application from Juliet High School. They receive their funding through grants. The benefits of the laser system: transferable problem solves, knowledge of technology, attractive skills for future employees. Their STEM club also uses the rotary attachment to create laser engraved tumblers with the school logo on it to raise money for the club. That's the other thing with the laser systems, is they are great fundraisers. You can make everything from keychains to tumblers to plaques, trophies, awards, nameplates, desks, anything you want to raise money. And so the machines can actually buy additional machines. So once you get that received through grant, the machines have made enough money to buy additional systems for it, in addition to using that fundraising to buy the raw materials, the sheet stock material. And so selling them into the store, using the students to sell to parents. And so the physical product is actually produced, so there's value in what they're doing. STEM education is one of the most common in this. STEM or STEAM schools already place a strong emphasis on the importance of technology and offer an ideal environment for laser systems to be incorporated into many different classes and subjects. Lasers can also be used in conjunction with other types of equipment. And this is something I can't emphasize enough. Just because a laser does so much doesn't mean it can't be expanded with other technology. For example, printers and lasers, so you can take a printer and print directly onto material and then use the laser to cut that material out, whether you're cutting a puzzle out that's been printed onto a piece of paper that's adhered to a piece of wood and then cut out as a puzzle, or if you have camera registration on your laser that automatically cuts it out to create keychains and actual physical products. CNC in lasers is ideal. CNC produces plaques and awards and stuff like that, and the laser finishes it. I always say where the CNC stops, the laser begins. So they combine together to create a whole nother benefit of, especially when you're working with multiple technologies. 3D printing and lasers, creating products and flat sheet stock on the laser system, and those complex, detailed 3D printings, and then combining them together to create a product using both technologies. Working with water jets and lasers. Water jets can cut through stone. They can cut through the metal. Lasers can't do that, but water jets can't engrave a photo on that stone. So the combination of working with multiple technologies in a STEM environment is ideal. And it could be as simple as hand tools, working with something like, saws and hammers and stuff to physically cut out and make a box with hand tools, and then sticking that box into the laser to engrave it, to decorate it, to enhance it, to cut out intricate openings. So the combination of all technologies work together in a kind of harmonious process, and that's where this education is beneficial. Here's a video of Ken and kind of a little bit of his background and what he processes. I'm going to let you watch here.
My name is Ken Hawthorne. I'm at ACE Academy, and it is a brand new makerspace. When I walked into position, they said, okay, we're ready. We want to do the full makerspace. And so I've spent all summer building out a makerspace here at ACE Academy. The Speedy 100 is the laser I have. It's the smallest and most value-oriented laser that like an engraving shop would use, which means our teachers can be using this all day, every day. Trotec, I think when I started to look at, like specifically for me, the tube on the Trotec seems like it's a lot more solid. So the engraving speed, that was also important. So when it came time to choose the laser, that also just the Trotec people, like I was super impressed. I really wasn't that shopping for it, but Chris, our sales guy, is like really accessible, long conversations, good after sales support. You know, 8th grade, our students are a couple years ahead, so we're teaching geometry, history in 8th grade. Like, you're relating the machine to math. You need to understand the machine, but without even turning the laser on. You are looking at, this has some software, this has some electronics, it has a physical chassis. So it's the most frequently used machine in the makerspace, and it is the one that we can draw out the most engineering and math lessons from, just talking about how it's actually working. We have a ton of cardboard. It is upcycling is better than recycling, right? So all the cardboard that comes into the school, almost all going to go through the laser or through some other different hand tools. I came across ACE Academy. I was very interested in the opportunity, and I have a depth of makerspace experience. I knew it was just not negotiable. So I'm not going to sign up for the job, and I'm not going to build a makerspace unless we have or an industrial laser. Don't buy a cheap hammer at the hardware store. Buy a good hammer. You need to get a laser that is going to hold up to your success as it's used more often. Not just in your curriculum in the makerspace. That is not the thing. It's when all the teachers are using the tool and are excited by the tool. They're all going to be using it in their curriculum. Don't cheap out. Like get the right tool for the job.
All right. Thank you, Ken, for that testimonial. He is absolutely right. I mean, the one thing about this type of space is you want a durable piece of equipment that can last. You know how students can be difficult on equipment, especially in a makerspace. These machines need to be able to be hardened in and work very, very well for long periods of time. The last space I want to cover here today is a college university. College universities, lasers are far more common in college and universities because they typically have, of course, the budgets for them. But they're also used in so many more departments in college, you know, from engineering, architecture, art and design, sciences, prototyping, material development. I've worked with college and universities for years, and they've literally pushed the limits. They've used lasers to help develop new technologies, to help develop new materials that never existed prior to that. And so it is amazing to me what I have seen actually created from lasers. I've got probably 50,000 plus operational hours on lasers, working with every material on the planet. And more times than not, these colleges and universities will even, you know, blow me away on what they're doing with these systems. And so this is a great space. And of course, if a student has access to a laser early on in their education, it's going to prime them to go to these colleges and universities that tend to have the laser systems as well. Typically in this space, the whole gamut of laser systems are available. Speedy series, as well as the Flex, using the dual source for engraving, for cutting. SP series is also more common in this space, large format type cutting, as well as the speed marker for high speed galvo marking, prototyping, working materials. I mean, I've seen them use it for everything from micro welding of plastics to industrial cutting of products that are going to be producing new types of technologies and materials. So the entire gamut of laser systems that we offer is typically looked at in this space. Technical institutions use lasers mainly for prototyping, but use does vary based on the schools and especially. Example, Georgia Institute of Technology put their Speedy 400 to work during the height of the COVID-19 to produce face shields, prototyping bag valve masks and ventilator systems, protective shields for intubation and other procedures. So when the call came in, they immediately took their laser and they spurred an entire marketplace. Right when the pandemic hit, the PPE was so hard to find that all the companies out there with laser systems jumped to it and started manufacturing it. And they were led by colleges and universities that jumped to kind of helping and design these type things, and then posted the files for free so that other laser companies could help out during that. And so we applaud them for things like that. The last one is Makerspaces and Fab Labs. Makerspaces and Fab Lab are, whether they're an extension of a school, university, library, or its own business entity operating outside the educational system. Makerspaces and Fab Labs, or fabrication labs, or Fab Labs, are a great way to bring laser technology to a surrounding community. So students that may had access to a laser during the school may eventually go out into the workforce, but may want to actually produce their own business or get something started. Makerspaces and Fab Labs have given them ability to do that. The benefit of Makerspaces and Fab Labs, like Ken's Makerspace that he was talking about, they give multiple equipment that most people just cannot afford and bring it all together, either in an educational standpoint or for a monthly fee. And that monthly fee gives you access to all this technology and allows you to build maybe a business or work a side business, or even just work on personal projects. Along with laser equipment, they typically have 3D printers, wide format printers, vinyl cutters, CNC water jets, as well as other machinery. I've seen large format CNC cutters, and they're a perfect addition to these spaces. The one thing that I have noticed at every makerspace I have ever worked with in the 21 years, and makerspaces have really come around in the last 10 years, is that the laser systems are always, and in every case, been the most popular product or tool in the makerspace, because they are the Swiss Army knife. They work with so many different materials, but you may still work with multiple combining materials as well. Traditional memberships and fees work as well in makerspaces, as well as hosting special laser training courses are always a great ways to pay for the lasers themselves. Additional products can be produced on it. The fundraising can be done with some of the technology to help pay for the makerspace, allowing the attendees to actually help working on a project or a product that is sold, which helps pay for it, so they can use their labor to actually help pay for a product which is sold to pay for the Fab Lab or the makerspace, or addition fees can be done on an individual standpoint. All of the above has been done. I even know of a makerspace that was put in a large semi-truck that was bought by a school system, and then that semi-truck had all the equipment in it and was a mobile lab. And then it went around to each one of the school districts, and those school districts would call it in, and it would sit up in a parking lot for a couple weeks while all the students did their projects, and then it would pick up and move to another school. This allows for maybe an entire district to buy one makerspace and then move that makerspace from place to place. It has been amazing to me what has been possible and actually what has been done in this market. Typical makerspaces tend to use the Speedy series. The Speedies are the fastest systems, and then also the R series, mainly for the people that are just looking to cut. Keeps that cost down, allows for a much larger field size for cutting. And so these are the more common systems for the makerspace products, or makerspace space, if you will. So the next one is why Trotec. I mean, there are a lot of different laser companies out there, but in my opinion, everyone tends to compare themselves to Trotec because Trotec is one of the leaders in the industry. We've been around one of the longest. We have by far the largest product line, the best support structure in the industry, individual sales, service, and support people in just about every state and country on this planet. So, and also a product line that can really kind of hit every one of these markets in a very vast organization. The other thing is Trotec tends to work on safety. Our systems are all class 2 lasers. They consist of a visible laser, safe for the eyes and exposure. You can also, the only exposure to potential lasers is a red dot pointer. All laser systems are safety interlocked and closed concept, offering users optimal protection without the need of any added safety or PPE. The systems can be opened up in cases, but typically are not done in makerspaces and schools. When systems are enclosed, it's as safe as your standard laser printer. So there's no safety requirements in schools because of that. Redundant safety systems built into every laser system that we make. Additional safeties include interlock keys, safety switches, protective covers, safety switches, main power detected, key switch motors, laser sources, electronics are de-energized with the key switch. Emergency stop buttons on some of the machines. Electric circuit is interrupted in the beam, and all movements are stopped if the emergency stop button is placed. So depending on which product that you go with, there's lots of different safety, and so that never is an issue. The fact that it can cut, mark, and engrave, it is far more safe than, say, a mechanical cutting system like a table saw or even a hand saw, because the machine will not work without the doors all sealed. Any one of those doors are open during the lasering process, the laser beam will disengage instantly. In addition to the Ruby software, I showed you a little bit of the Ruby software earlier. Ruby software just gives the ease of use, that unbelievable method of being able to basically send an email out to all the different students, and that student will then have access to the Ruby in a web-based environment, or in an internal network onto that school, so that you're not paying for additional software. They can design within Ruby. They can import their files directly from their tablets or their laptops or their Chromebooks or their MacBooks. We're not limited to operating systems, so you can be running from a Mac, a PC. So it really opens up that compatibility. In addition to working with just about any design software. You can run your lasers from Adobe Illustrator, CorelDRAW, AutoCADs, SolidWorks, limitedly on the 3D stuff, but most of it, as long as it can produce a CAD-based 2-dimensional drawing and it's vector-based, those drawing programs can be converted to formats like a PDF, SVG, AI formats, and then be directly brought into the Ruby software and then operated. All of the lasers can be connected to a single network, and the ability to process jobs remotely from any computer. So students can design, develop, make sure that they run it. Each one of their jobs are separated so that somebody else on another computer don't have access to them. The administrator, teacher, or person that's overseeing it all will have full access to give them ability of operation of the laser. They can turn it off. They can give as much or as little connectivity to that laser as they want. So all this is built into the Ruby software. If you want to know a little bit more about the Ruby software, how it works, what it does, last month's Third Thursday was on the Ruby software. You can actually go through in depth on showing how it works, the process of how it works, how to set up remote computers, how to control administrative rights. All this information is step by step. Scan this QR code if you want to watch this, or go to the Trotec Laser USA YouTube channel. The ceramic core is another huge advantage for Trotec. Ceramic core lasers is the current culmination of technology for lasers. Now, the ceramic core is basically the engine inside of our laser systems. The ceramic core produces a longer lifespan, and it can pulse much faster. And this is what allows the Trotec lasers to engrave so much quicker. So being able to run much longer, use less energy, and pulse faster allows these laser systems to both last longer as well as produce more products per for the time that the laser is operating. This is built into the laser system, and they're going to give you that durability and last and quality. And it really sets Trotec laser systems apart from any of the competition because they don't have this technology. Impact technology on Trotec systems allow for all the sensitive components, optics, belts, bearings, electronics, laser, optics path to be shielded. And that shielding is actually going to be critical for all those components and protect the laser from dust and debris produced from that laser processing. This extends the life of your laser, resulting in much less downtime, less maintenance, and overall really does prolong the life of the laser and allow that uptime to be much higher than the downtime. Also, the build quality. Machine construction is unbelievably durable. I've used just about every brand of laser on the marketplace today. And when you take a closer look to a Trotec laser, you definitely get what you pay for. The build quality on a Trotec is unmatched in the industry. Tough metal housings withstand a certain amount of wear and tear. And they're just built to last. You know, you can look in the industry, look at the used market, and you really do find out what kind of return on investment you can get. Definitely the highest resale value of any used machine on the market. And that basically is a testament to how well the laser systems last. Another thing that Trotec offers is an entire project material line. We offer engraving plastics, acrylic sheets, wood panels, laserable paper, and so much more different types of materials. Two-tone plastics in just about every color combination, metallics, different types of woods, MDFs, plywoods, laminated veneers, solid core woods, raw woods. And so this gives the ability to kind of combine it all together. Plus, of course, all those materials are combined into our materials database and pre-programmed on your laser system to be automatically done. New materials and existing materials can also be added to the database, but it would require in some cases to have that setting dialed in if it is not a common material. But having all these materials available, catalogs of materials combined with power settings and a durable laser system really gives the entire project, the entire, basically everything you need under one roof. The next is I'm going to cover some resources. The one question I get a lot from educational standpoint and schools is resources. Where do I get this? Where do I get this? How do I get that? So we have our website. We have many, like hundreds of DIY samples, step-by-step application tutorials with free laser files, tips for laser users, parameters to help you to produce optimal results, beginner guides on lasers, guides, handbooks, all available for download. We also offer our YouTube channel. I myself create several different channel or episodes called Laser Hack series. I've got over 30 of those on there, which are tips and tricks on how to make projects easier, how to do processes. And so these are great hacks that can also be used in an educational standpoint. They're right on our YouTube channel, very accessible to it. We have another one called Can You Laser It, which are basically pushing the limits, you know, beyond what I thought is possible. Let's go ahead and try it. So let's engrave on beef jerky or Play-Doh or the side of an eggshell. We've done it. Take a look at that on our YouTube channel. We have featured applications. The featured applications show you the process on a video standpoint, give you the file, as well as the instructions on how to do that file. Third Thursday workshops like this. We have done dozens of these now. So this content is available on our YouTube channel and can literally be just played in front of the students to learn everything you need to know about a material like plastic or wood or acrylic or markets, you know, like this. And so these webinars are available all on it, as well as tutorials, tips, tricks, and so much more. Trotec also offers laser curriculum application applicable for secondary application, including outline learning outcomes, instructional strategies, assets, and additional resources such as personal project management, science and history, materials, supporting tools, laser operation, graphic essentials, and health and safety of the laser. These are all offered resources for schools. We also have a vast network, 13 different locations across the country, and these locations are available for people in that local area. So you have that local sales, service, installation, training, and support. Many of these locations also have service techs at them. So we have a vast network, all owned and operated by Trotec across the country, so that you have that access to that support when and if and when is needed. A few more resources here. Here's the design files that we covered today in the course. So if you want the design files, I didn't do the very first one because it was designed directly in Ruby and there's no actual file, but that was a simple name tag. But the name, the wall sign, the little rocket, and the phone amplifier files, project instructions are all available for you to download. So you can download the file. I typically offer the file formats in both PDF, AI, and CDR or CorelDRAW formats. And so multiple formats so that you can download these files and have access to them should you want to cut them out yourself or modify them. Another resource here for you is external resources. There are so many other maker spaces out there that offer projects and inspirations on how to make Fab Labs. There's a QR code you can actually download on how to actually set up your Fab Lab and how to basically create projects. Down below here are also a line of companies that have developed files in the marketplace for free. Between these 6 different companies here, the Instructables, 3-Axis, MakerBot, Dezen, Admead, and Free Pattern Area, there's over 25,000 free laser files. And the way these work is if you have a cool file, upload it onto their site and share the wealth and keep it going. Basically pay it forward. So if you need to download a file, make a modification to it, or if you just want to cut something out on your laser and you don't want to actually design it, these are a great resource for finding those files. Now, a lot of times they don't have the instructions. You may need to, understand your laser and work with it. But these are definitely a great resource for that. Another one is, if you want to pay for it, is the Etsy. Etsy has over 250,000 files now, but most of those are for a couple dollars to buy. And so, but there are a lot of resources out there. Instead of designing the files, maybe you start with one of the free ones and learn what files should look like. Maybe cut those out, and then it'll give you ideas to create your own. Here is the last resource that I wanted to show today. This is a great one, so I set it aside from the other one. It's called Maker Design Lab. They are an actual maker lab, and the benefit of this one is, yes, they give also projects and designs and files as well, but what they offer are file generators. They've put together many new online generators to create boxes, puzzles, gears, mazes, nesting projects. And so you can basically go into their little box generator and it'll add all the little notches to compensate for the beam diameter, producing a perfect notched box to put together. It'll ask the material, the beam diameter thickness, the material thickness, and then you put it in, it instantly generates a box that can be laser cut and then put together with realistically no effort. Same with puzzles, gears, gearing ratios. You can put in the ratio and it creates all the gears that can then be cut out and give you that exact gearing ratio. These are free file generation wizards. They're right on their website. If you want to create a maze, you indicate how many paths and how many outlines in the little wizard, and then it spits out usually an SVG file that can be imported directly into Ruby or in your design software, edited, modified, and then laser cut. As well as nesting, you drop your file in there, it'll nest it for you to get you the most efficiency out of your materials without having to manually do it or pay an additional cost for a nesting software. In addition, they also have project experiments, tutorials, and tips. And so I really wanted to showcase this, especially for education, because they've done a great job in putting together all these generators. Because, yeah, you may have hundreds or thousands of free files, but these are generators that will produce a custom file for you without having to design it from scratch. Another external resource is the SME Prime. It's a partnership in manufacturing education foundation. So this is a foundation that's really going to help with grants. It's going to understand engineering programs, curriculums, and it's just a good professional development foundation to kind of help you with these types of questions that you may have. If you want to scan this QR code and learn more about this foundation, you can scan it, and it will definitely help you in this marketplace. Another one a lot of students and colleges and schools will use is your GoFundMe and Donor's Choice type things. These are crowdfunding type stuff. work very, very well in this marketplace because you can offer simple things like keychains and tumblers and stuff like that as a incentive to pay basically certain percentages towards a laser. And once that laser is purchased from the crowdfunding, then of course the physical tangible object can be engraved and then given to those person that help pay for the laser. So it's a great way to crowdfund for the laser system. And then once that laser is purchased, you can use that laser to build a product, maybe sell that product to help buy additional lasers or buy additional materials. So another method besides your grants, because grants, of course, can be limited, they can be hard to find, they can be also very time consuming to get, and it also requires some skill to do that. And so if you've got a community that's around it, wants their school to be high tech, this is also definitely another resource out there for you. The August deal of the month on our materials, if you want to scan this QR code and go to our material website, is on our TroCraft Eco material, 20% off currently. So this is a great deal to if you want to go onto our website and actually buy these materials for your educational school. All right, thank you so much. Now I'm going to go ahead and move on with Ken again, and we will answer any of your questions that you had during the course. Welcome back, Ken. Thank you again for joining me.
Thank you. That was a lot of fun to see.
Outstanding. Hopefully you got something out of it and got some information for it.
I did actually pull up a webpage on those shape generators. So
yeah, that's a great one. You go on there and it's like you just type in the dimension of your box. It adds the dovetails and notches all for you. So all you have to, and you can even put in the beam diameter to compensate, so it'll give you a really tight fit. So definitely a good an advantage of trying to design it yourself.
Absolutely.
All right, so let's go ahead. Ken and I will now go ahead and answer any of the questions that you have. We didn't have a huge amount of attendance on this, but we'll go through and answer what questions we do have, and then we'll bid you goodbye and we'll move forward. All right, we have the first one here. At Ken, what is your favorite thing that students have made in the Makerspace with the Speedy system?
Definitely upcycling cardboard. Let me just grab it for you. We've got a lot of parents. We've got a lot of Amazon boxes, and
all right. Oh wow,
something like that. So you can see you can see the light going through it, but it's a lot of fun because you have students who are artistic that want to participate just in painting, or you have students that want to run the laser. So there's many different layers to this, or just the physical assembly of it. But it's just super glue, cardboard from an Amazon box. There's a great cardboard knife called a canary cutter. It's like $6. And we just harvest cardboard as it comes in the school. Parents bring Amazon boxes. We, just like a butcher in a meat shop, we have a cardboard library. So that's the type of project which can involve students of all ages.
Awesome. And then that costs nothing, basically. It's one of those, as I call, found material, and just reusing. It's just going to go in the trash anyway. So it's a great one to do that with. Awesome. Anything else you wanted to share that you've done?
Yeah, I'm just getting ready now for geometry starting next week. Our students are coming back. So I have just a couple minutes here, but basically their geometry notebooks. We're making a book of questions for them. And then in geometry, we try to get students to value their writing. So we're giving them fountain pens. I don't know if you can see that, but it has a student's name.
There you go.
It has a little design. We're going to open geometry with radians. And then probably the last thing I can show you before I have to go is, for those of you who know Raspberry Pi and Arduino, can you all see that? So right now, since I'm in a new school and the students are going to learn laser for the first time, I designed this case, and it has the Arduino and the Raspberry Pi there. But what's cool about it is it has strain relief. So if students are working in pairs and they're kind of tugging back and forth as they're using the breadboard,
I got it.
That's not going to come out.
That's not going to come loose, yeah.
But that's a scaffolded thing because they're going to learn Fusion for the first time. So basically, here's the file, here's the design. Now, how would you modify it? What considerations would you have building it? So they're going to actually be evolving their case designs in their lab.
Awesome.
So,
Well,
Yeah.
thank you for sharing that. It's really neat to actually see what people do in this type of space. All right,
Absolutely.
let's go. We've only got a few more questions here. Let's go ahead and answer the few questions we have left here, and we can get going.
60 seconds. So
I'm sorry, you have to go?
soon.
Okay.
Okay.
Are the laser systems compatible with most graphic software? I can answer this. Yes, definitely. The graphic software does need to be vector-based in order to work. So any vector-based graphic software that can actually produce a cut line or a vector line, most commonly used is your Adobe Illustrator, your Corel Draw, your CAD-based. Things like Inkscape is a free one that's out there, and there are so many other ones that are out there that are actually free that can work. So if you can draw a line and it's vector-based, we can process it with that. What type of training is offered for teachers and instructors? That's a great question. These type of schools typically will get a full-on hands-on training that comes out from the salesperson and instructor that will come out to the school. And so the school, when installed, they'll help install the system. We will walk you through the schools exactly how to set it up and exactly how to operate and run that machine. So you have to go, Ken?
Okay, see ya.
All right. Thank you so much for joining me. Thank you, Ken. And I'll go ahead and answer the rest of these questions, and we'll be done. And so, yes, all the education training is covered. And then, of course, you have that local support. We have our online support so that you can go to our website. We have our technical support departments to help with any of those technical questions. Resources like myself online that you can check out for these tutorials, training, laser hacks, as well as, of course, that physical training on the hands-on machine at your school or location. All right, that's all the questions we have. Thank you so much. Feel free to ask us any other questions. You can post them in the comment after this course is finished. Feel free to reach out at all. I thank everyone for joining me today and watching this seminar. Let us know if you have any questions, and have a great day.